Our fourth experiment will be from the ninth lesson. Today, we are diving into Newton's first law of motion with a fun and eye-opening experiment called Buckle Up. Quick trivia to kick things off. Did you know that Newton's first law is also called the law of inertia? It says that an object in motion stays in motion unless acted upon by an external force. That's why seatbelts are lifesavers. They stop you when the car stops suddenly. In this experiment, we simulate a car crash using toy cars and dolls to show how inertia affects passengers and why seatbelts matter. The goal in this experiment is to demonstrate how Newton's first law applies during collision and how seatbelt helps prevent injury by counteracting inertia. Now, the materials we use for this experiment are the following: a 4-meter string to pull the car, a toy car instead of dynamic cart, 2 to 200 gram hook masses, which our case we use a 2 to 200 gram batteries masses, 2 hair scrunchies as a seat belt, 2 small dials as a passengers. Instead of 2 pulleys, we use folder to create alternative pulleys to guide the string, and a book instead of wooden blocks to stop the car. We place the doll in the toy car, once with a scrunchy seat belt, once without. Then we pull the car using the string and let it crash into the book. What happened next was physics in action. Now that we've seen the crash, let's break down what really happened. Time to answer some key questions and analyze the result. First question: what stopped the motion of the doll without a seatbelt when the cart crashed to stop? When the toy car crashed into the book, the doll without a seatbelt did not stop with the car. It kept moving forward and was thrown out of the vehicle. That's inertia in action. The doll was still in motion even though the car had stopped. There was no force to stop the doll, so it kept going. Second question: was there any difference from the doll with a seatbelt? The scrunchie acted as a restraint, holding the doll in place. When the car stopped, the seatbelt provided the external force needed to stop the doll too. It didn't fly it forward. It stayed safely in the car. That simple difference, one elastic scrunchie, completely changed the outcome. Conclusion and reflection. We conclude this experiment show how Newton's first law of motion works in real life. When the toy car stopped suddenly, the doll without seatbelt kept moving and was thrown forward. This happened because of inertia. There was no force to stop the doll. The doll with scrunchy seatbelt stayed in place because the seatbelt provided the force needed to stop it. This experiment helped learners understand why seatbelts are important. Our experiment proves that even simple materials can reveal powerful truths about motion and safety. Next time you hop in a car, remember, buckle up, not just because in the law, but because physics says so. Stay curious, stay safe.